In this video, you'll begin to describe how the values of a, h, and k are going to transform a parent function and turn it into a child function. So just to review, these are the parent graphs that you should be familiar with, and you should know these very, very well. We have the constant, which is a horizontal line where y equals 1, the linear parent function, absolute value, and quadratic, which contains the squared function in it. So you should know these parent functions and the tables that associate with them very well at this point in the course. In the previous video, you learned how the values of a, h, and k transform a parent graph when they're added to that parent graph. You talk about how a is a vertical stretch or shrink depending on its value, how h is the horizontal shift of a function and it moves opposite of what you expect, and how k is the vertical shift of a particular graph. So what we're going to do is we're going to now start looking at child graphs and making predictions about how we could get there, what we would do to the parent graph in order to create that child graph. And we're going to use these values of a, h, and k in order to do so. So for each equation below, so we have two examples, example 1 and example 2, we're going to describe how the parent graph will be altered in order to create its child graph. And here I created the parent equation with its transformations for the absolute value function, but remember the a, h, and k work the same in every function that we see. So what we're going to do for each of these is we're going to determine what our a, h, and k values are, and then we're going to identify what is going to happen to our parent graph in order to create those particular functions. So here in the first problem, we have f of x equals -4 absolute value of x plus 9. So I can see that the absolute value parent function is going to be modified to create this particular child graph because it has the absolute value function in the equation. Now I need to identify my a, h, and k values. Well, a is always out here in front of the function, in front of the entire absolute value. So here we see that a is a -4. We then look and we see that h is contained inside of here with x, and h, in our case, is 9. We then have a k value that is outside of our function, which we can see there isn't one out here, which is an implied +0, so k is just going to be 0 for this particular problem. So what we can do is we can use these values of a, h, and k to describe how we're going to alter the parent function in order to create this child function here. So this a value of -4, the first thing we do is we look at just the number portion. And the number portion of 4 is bigger than 1. And what this means is it's going to vertically stretch because it's going to multiply every point by 4 and make it 4 times as tall. So it's going to vertically stretch that parent graph by a factor of 4. Then the next part here is because this is a negative, this a value has a second effect on this child graph. So this negative value also means we're going to have a vertical flip. So in the case of this particular problem, the a value actually impacts our parent graph in two ways. It stretches it and it flips it. Then from here we have our horizontal change, which is the h value. And this is going to horizontally shift our graph. Now remember, h works the opposite of what we expect. It works the opposite. So if this is a +9 here, it's not going to go in the positive right direction, it's going to go in the negative left direction. So what this h value of 9 does is it moves the graph, or it shifts the graph 9 units left. And then finally, this k value of 0, well, k is typically our up and down change, how we shift the graph up and down, but because k is 0, there is no change here. So we've now learned that in order to create the graph, the child graph, in number 1, it would vertically stretch by a factor of 4, vertically flip, and move the graph 9 units left from that parent graph. So now if we look at example 2, we're going to kind of go through that same process there. So we're going to identify a, h, and k to start. So here, our a value, remember, is right out in front of the entire function, which is here, in this case, 2/3. We then have an h value of, well, typically it's right in here inside of the function or inside of parentheses, but we have an x by itself. So really what this is saying is x plus 0 quantity squared. But because the 0 means that you're not adding anything to x, the x value is just by itself instead. So here our h value is actually 0. And then our k value is added on the outside, which in this case is going to be negative 8. So now that we've identified our a, h, and k values, we can move on and we can talk about how the parent function is going to be altered in order to create this graph. So our quadratic parent function first is going to be altered by this a value here. And this a value is positive, so there's no flip happening this time around. But this time around, a is equal to 2/3, which is less than 1. So what this means is we're going to shrink our graph to have 2/3 of the height that the parent graph has, which means we're going to vertically shrink this graph, or this parent graph, by a factor of 2/3. So we're going to make it 2/3 as tall. Then, because h is equal to 0 here, that means that h has no horizontal shifting change. So h has no impact on our graph if it's 0. And then a k value that is negative, remember that k is our vertical shift, so up and down, and it works as expected. So this graph is going to essentially move, so it moves the graph 8 units down. So in order to create this particular child graph, we would vertically shrink the parent graph and then move that parent graph 8 units down.